Poppits, they are completely awesome and fabulous for doing primary maths with. In this video, I'm going to run quickly through some of the fabulous maths you can do with your children. I'm going to cover instant recognition of small numbers, beginning addition and subtraction, working with the structure of fives and ones, so that's recognizing it and calculating with it. I'll be looking at multiplication and tables. I'll explain how we teach division brilliantly with this thing. I'll show you how we can use it to find fractions of amounts, and then we'll look at square and triangle numbers with the poppit. So if you only want part of the video, just scroll through and you should see big titles for each of those sections so you can find what you're looking for. So beginning at the beginning, we want children to instantly recognise, that is subitize, numbers up to 4. So you shout a number, can they pop it? Number 1. Number 4. Can they pop number 4 in a different way? And another way. And of course you can show children numbers very quickly. What was that? And they have to name the number. So we can have lots of fun with the very beginnings of maths. Okay, next step is to begin addition and subtraction. So we want to start with small numbers like 3 add 2. Pop it. So there's the 3, there's the 2. What's the answer? So once they've got the hang of addition with small numbers, then we can move on to subtraction. What's 5 subtract 1? Pop 1 back. We can see it's 4. And we can say we had 5 and we took 1 away, or we can count on from the 1. This beautifully shows the part-whole structure of subtraction. And here's a link to a video on that if that's something you want to understand in more depth. Okay, moving on. The next stage, and this is brilliant for children aged 5 to 7, is to work with the structure of fives and ones. It's the structure that's in the rake and rake. It's in 10 frames. It's in my wonderful coat hanger here. And we get it on the poppit by getting rid of the top row, the red row. Traffic lights, red means stop. We're not going to use the top row just now, so we're going to get rid of that. And then what we've effectively got are 3 10 frames. With 10 frames, we always fill them in columns and we start bottom up. And what we're trying to do initially is get children to instantly recognise numbers when they're in fives and ones, which is tally formation. As an adult, if you saw 17 in a tally, you'd know it was 17 instantly. If you saw 17 lines, you wouldn't know it was 17. It'd be a really difficult thing to do. So we want children to get to recognise that structure. So if we said number 17, pop it 17, we want them to do it in the right structure. So 17 will look like that, and they're starting to see those. We can block out this top line if that helps, especially if children are working on desks. They can just put some cubes in them so they can't see them, or you can cover them with masking tape. It's a little bit more difficult for me because I'm working upright, so I'm just going to cover them with my fingers. So there's your 17, and then we can do additions and subtractions. What would 17 add 6 be? Well, we can see that 6 going on as 2 3s. And we're starting to use and experience the partitioning of small numbers within addition, which is great. If we go back to the 17, we could look at 17 subtract 4. 17 subtract 4. What's the answer? Can you pop it? And they're popping out 2 2s there, splitting the 4 into 2 2s to see that the answer is 13. And again, that reveals the part-whole structure of addition and subtraction beautifully. So you can see subtractions being taken away. We've taken away 4, or we can see it as being counting on, or just splitting the total into 2 groups. If you want to understand more about the fives and ones structure, here's a link to a video on that now. Right, moving on to multiplication, and of course we're doing multiplication as array. So if I said 3 4s, pop it. You want to see an answer that's 3 by 4, whichever way round it is. And there we have beautifully the commutativity of multiplication, that 3 4s is 4 3s, because it just depends which way you look at it. So inclusive, so wonderful. Every child's going to want to be part of doing multiplication and doing their tables up to 6 times 6. An array is a wonderful way to organise multiplications. It takes you on into much more complex multiplications like long multiplication and mental multiplication and multiplication of fractions. So we want to set up this foundation of visualising multiplication as array. Next thing, division. Pop it for 10 divided by 2. Well, if we're dividing by 2, we need to be too high, and we need to pop it until we've used 10, and then the answer is this row here. How many in it? It's 5. Everyone can do that, can't they? Suddenly division's really easy. And just as the part-part-whole structure unites subtraction as taking away and subtraction as counting on, and it just being a missing part, so array, organising things as rectangles, unites division as counting groups and division as sharing fairly, and division as just being the missing number in a multiplication, which is what it is. Let's just look at another one. What's 16 divided by 4? Pop it. There's our first 4. Next one, that's 8. That's 12. Okay, and it's 4, because it's 4 in both directions. So 16 divided by 4 is 4. You're just finding the missing side of the rectangle to answer the question. It's a really powerful way to understand division. Here's a link to a video on the foundations of division if you want to understand more about that. Next one, fractions of amounts. Can you find 2/3 of 18? 2/3 of 18. Well, if we're doing thirds, we're going to need to put that 18 into 3 columns. And there it is in 3 columns. And now we can see it in thirds, and we can see that 2/3 of 18 is 12. How cool is that? What about 5/6 of 24? 5/6 of 24. Well, if we're doing sixths, we're going to need to be 6 columns wide. That's 6 used, 12, 18. That's our 24. And we want 5/6. So we need 5 of those columns. That's 20. Square numbers. Pop me 5 squared. And there it is. And we can count it. It's clearly 25. That gives children such a deep sense of square numbers. And what about triangle numbers? Well, some children would see them like this. That's your first triangle, which is just a dot, which is a bit odd. But as we get into it, there's your second, your third, and some children can clearly see the triangles. The stripes of colour are a little distracting, so some children would rather see them as triangles like this. And of course, we can continue. There's your next triangle, and so on. And you can go beyond 6 because you can reason beyond 6. So the 6th triangle number is going to look like this. What would the 7th triangular number be? Have a think, talk to your talk partner, explain your thinking. What are your answers? And remember to cherish wrong answers and get children to explain how they got them as well, because they matter. And I do so mean that. I remember walking to school with my daughter and doing a few tables questions with her. And I asked her what 6 sixes were, and she said they're 38. Now, I could have just said, no, that's wrong, think again. But instead, I said, well, how did you get that? And she said, well, I could see it was 3 lots of 12. And 3 lots of 12 are 36. 36. Sorry, got it wrong. This is such a wonderful tool for that kind of learning. I've put some approximate ages on the different topics, but this is a game. And when you do maths with games, reality is broken. It's a wonderful book by Jane McGonigal, and it is so true in practice. When you do maths with games, extraordinary leaps of learning can be made because it's a game. It's not a maths lesson. And nobody really understands the logic of it, but it just happens. And it's inclusive, not just for the children, but for the adults involved in the maths as well. They can start to see things they never saw before. So as teachers, we have had the roughest time ever. Now it's time to have some fun. Somewhere, someone in your school needs to authorise buying a class set of these. And if they won't, then personally I would just go and buy about 4 myself and do them in small groups for the kids and just have fun. We so need to have fun. If you liked this video, please could you do me the huge favour of sharing it with some friends or colleagues? I'd be so grateful. And if you'd like to see more of my videos, you can find a full list of my maths professional development videos, which are all free at www.authenticmaths.co.uk/videos. Let's go out there and make sure every child we teach becomes a fabulous, confident, creative mathematician. Bye for now.